note that when you take the nth root or the square root, okay, or in this case the fourth root, as long as the root is actually even number, alright, there is both positive and negative. So the value of a in this case will be 2 or negative 2. Then after that, for question 6, you're given this, and in part I, is given that x squared minus 3x minus 4 is a factor. So when you have a quadratic factor, the quadratic factor typically can be factorized, okay? So we get x minus 4 and x plus 1. Okay, so if this one can be divided by this, it can directly be divided by each of the parts as well. Okay, so we will choose x to be equals to 4. And the remainder will be 0 because it is a factor itself. Okay. Then we have one equation over here also. This one 60. Okay. Then we get one equation here. And if I have x plus 1 equals to 0, we choose that x equals to negative 1. And you'll eventually get a plus b plus 5 equals to 0. So a will be equals to negative b, negative 5. And with these two equations, we can solve simultaneously. I'll leave the solving to you. You should get a equals to 2 and b equals to negative 7. Okay, so do check your answers. Okay. Then in part 2, to factorize the whole thing completely. Okay. Completely with the value of a and b already, you just have to do long division with the x squared minus 3x minus 4. Okay, so do long division. Okay, and you will get that the other factor should be 2x minus 1. Okay. Then lastly, question 7, wait, what was the issue? May I know? You don't understand the question? But do you understand what I've been doing already? Do you understand what have I been doing? Then do you think you can do question 7 alone? Can I try? Okay, so I don't go through. Alright, but take note, question 7, your answer for A should be 3. Answer for B is negative 11. Okay? Any issues? Alright? Okay, if not, please submit your homework to the front. Okay? 3, right? Okay, we were looking at factorizing cubic expressions. So we make use of SOAP SOAP, right? Okay, to know when is it that it is going to be of positive or plus or minus sign. Okay, when we are looking at factorizing these two cubes. Okay, this sum of cubes and differences of cubes. Okay, so slope represents same, opposite, always positive. So the operation here is the same. Then after that, opposite, followed by always positive. Okay, so that is a thing that we have already covered in the previous lesson. Today what we're going to be doing is about factorizing other forms of cubic polynomials. So for instance, if I want to factorize things like this, then surely the formula, the identities that we have learned earlier will not be able to apply. Okay? And how are we supposed to go about factorizing this kind of equations? Okay? We will have to make use of factor theorem. Okay? We try to go in a more smarter way, although it's a bit like playing cheat. Okay, we'll make use of our calculator. So make sure that you have your calculator with you. Okay. So in general, we will go through in 3 steps. Factorize something like that. Okay, so how do we run through these 3 steps in terms of solving? Okay, so and what do I mean by making use of calculator? Okay, I want you to all go to your calculator. I think all of you know how to solve quadratic equations using calculator, right? Okay, so go through the same format. Go to your equation setting. Okay, then after that I want you, if you're using the Casio one, right? Okay, when you choose mode, right? Number 3 equation. Right, then you go to number 4, alright, the one that has cubic. So choose the one that has the cubic one. Okay, anybody not sure? Not following? Alright, so go to the same page as per how you are solving quadratic equation. Alright, then after that, but you choose the cubic one. Okay, so the A value will be 2. Okay, B value is -5. C value is 1. Okay, and then D value is 2. Alright, I hope that you're following. You would get a few values in your calculator now. Okay, you will find that if you're using the Casio one, x1 is -half, x2 is 2, and then x3 is equals to 1. So you should be getting this in your calculator. Alright? So using the calculator, it will help us, right, in not in avoiding the whole try and error kind of process. Okay, because we want to use factor theorem to decide what is the first linear factor of this cubic polynomial. Okay, we want to know what is the linear factor. So what is the x plus 2 or x minus 2, that kind of stuff. Okay, linear factor. Alright, so with this, okay, you just choose one number, any number that you want. Okay, usually I will avoid the fractions, because with the fractions itself, this will tell me that the factor, okay, will have to be 2x plus 1. Because when 2x plus 1 is equals to 0, x is then equals to -half. Alright, so fractions tend to be slightly trickier. Okay, so I will prefer to choose those that are integers, because when the solution is 2, okay, it will tell me that the factor will have to be x minus 2, and this one will have to be x minus 1. Okay, so what do I mean by that? So when I have this kind of question, first of all, I name this function itself. Okay, then after that, I just choose anyone. I'll choose the integer. So let's say, for example, I choose x equals to 1. Simple calculations. I will find that fx equals, when x is equals to 1, I replace all the x with 1. surely, okay, when you press this into calculator, you will get the value 0. Okay? Reason is because these are solutions to the situation when this polynomial is equals to 0 itself. Okay? So definitely when x equals to 1, you will get 0. Okay? You cannot, alright, skip through this process. You must do this process, okay, and then after that claim that x minus 1 is a factor of fx. So using a calculator is to just ease the process, alright, in determining, okay, what value to substitute. Because otherwise, you will be going through having to test out every single number, okay, that you are familiar with to see whether you will get 0 or not. Okay? Does anyone not understand what I'm trying to say? Alright, so use calculator to do this process. Now that we have x minus 1 is a factor of fx already, step 1 is clear. Okay? Now we go into step 2. Okay, we need to perform the long division. Okay? So we will get 2x cubed minus 5x squared plus x plus 2. Long division x minus 1. Long division, your remainder will be 0 because you're dividing by a factor itself. Okay? So long division here, okay, step 2 is done. Now we factorize the question. Okay? So it will be the divisor times the quotient. Okay, then where does step 3 come in? For every quadratic factor, this is a quadratic factor. Okay, we must always check to see whether it can be further factorized or not. In this case, surely it will be able to further factorize because I know there are 2 other solutions, right? Okay, so okay, this will be the fully factorized form. Okay, does anyone not understand what I'm trying to do? Okay, so when you're doing factorizing, okay, you cannot make use of the calculator and tell me this answer. You need to go through these steps. Okay, yes, Jared. 2x plus 1 minus, wait up. Oh yes, sorry. Yeah. Cannot. You cannot, okay, use this and then tada, your answer is out. No. Okay? You must go through this. Alright? So you need to know how does this get generated in the first place. So the whole point of studying maths okay, is to know the whole sequencing and the whole process. It's not about getting the answer. Okay? Getting the answer is not the most important thing. Okay. Any questions? Otherwise, let's move on. Okay. So we know how to factorize already. Now we go into how to solve a cubic equation. Okay, so solving a cubic equations technically is the same process. Alright, it's a similar process. You have to do your finding a factor, okay, long division, and then factorize, and then you can solve. Okay? So let's look at try 16. they want you to find the real roots of the equation. So when you ask to find the real roots, it is as good as finding out what are the solutions to this equation itself. So same process, okay, we let fx to be this cubic expression. Okay, I'd like you to press into your calculator and tell me what are the solutions that you're getting from your calculator. Okay, all press your calculator now. What is it that you see from your calculator? You all get 1 and 3 only. Okay. Okay, there are only 2 solutions in this case, y and how, alright? We need to be aware that whenever you have cubic equations, cubic polynomials, okay, there can only be a maximum of 3 roots. Okay, 3 real roots. Okay, can you only have maximum of 3 real roots. So you can have 1 real root only, okay, 2 real roots, or in fact 3 real roots, okay, at most, right? So in this case, they only gave you 2. That means that one of them is likely to be repeated. Okay, so when you have 2 real roots, so maximum of 3 distinct real roots, so when you have 2 real roots, right, it can be 1 distinct and 1 pair repeated. Okay, then after that, if you have 1 real root, you can have a case of just 1 only, then the others are complex. Okay, later on if I have find an example, I'll show it to you. Okay, so going through the process, okay, we choose maybe x1 equals to 1. Alright, so when x is equals to 1, surely we are going to get 0. Okay, then you conclude that x minus 1 is a factor of fx. Then again, we go through the long division process. Minus 6x plus 9, right? We can further factorize the quadratic part, which actually gives us x minus 3 bracket square. So it is x minus 3, okay, that is the repeated factor. I erase this side of the whiteboard. Minus 1 times x minus 3 square. We have not yet solved the question. The question wants us to find the real roots. So when fx is equals to 0, which is actually this whole polynomial equals to 0, okay, that will mean that x minus 1, x minus 3 square equals to 0. So it is x minus 1 equals to 0 or x minus 3 square equals to 0. And clearly we can see that it only happens when 1 or 3 are the solutions, okay, to these equations. Okay, so that's how we solve. So when solving a cubic equation, we can only do it by factorization. I want to solve these cubic equations. Okay, question says that you can leave your answer in cert form when necessary. Alright, so we tend to actually in A-Maths leave our answers to cert form. We leave it into simplified certs as far as you can. Okay, so in this question itself, can you press into your calculator and tell me what is it that you can find? Okay, what are the solutions that you see from the calculator? What do you see? Kenny, what do you see from your calculator? Okay, we have a negative 6.46. In fact, it's a very long decimal. Okay, what else do you have? Kenny, continue. X equals to 1 also. Anything else? Okay, 0.46. Okay, surely when we're given these three options here, we will not want to choose the decimal. Okay, because it is not helpful in helping us to decide what is the linear factor. So that's why we always stick with the integer. Okay, by the way, I noticed that all my examples I keep choosing x equals to 1. It may not always be the case, right? Sometimes x equals to 1 is not an answer. So any of the integers will do. Okay, so when x is equals to 1, by the way, you must show this substitution. Okay, the substitution of x into the polynomial, you need to show it. It is an important step. Okay, so f1 is equals to 0, then we say that x minus 1 is a factor. Okay, I give you maybe 2 minutes. Okay, do the long division and tell me what is the factorized form. Okay, we are on it. can x squared plus 6x minus 3 be further factorized? Okay, it can't be further factorized, right? Because surely we know that we're going to get decimals. Okay, then how do we go about solving in this case? Okay, so solving process remains the same. Fx will be equals to 0. That will mean that x minus 1, x squared plus 6x minus 3 equals to 0. So, we will be able to derive out these two things. Okay, this one is easy to solve. We know that x equals to 1. In this case over here, this is none other than a typical quadratic equation. Okay, so for quadratic equation, we always use the quadratic formula to solve. Right? What is the quadratic formula? The one that is negative b plus minus square root b squared minus 4 is equal to a. Okay? So, use that formula. Okay? Because the question specifically says that if you answer to third form, alright, you will have to leave it into third form. So, calculate the discriminant inside the square root. Would get 48. Okay. Now let's practice a bit of our search. How do we simplify square root 48? Charmaine, how do we simplify square root 48? Square root 48, how to simplify that? Square root 4. 48 is equals to what times what? You realize that 12 times 4 doesn't quite help you in doing the square root, right? So we always try to get the perfect square out, so that's why we will choose 16 times 3. Okay, so 16 times 3, square root 16 will give you a 4. Hence, square root 48 will be 4 square root 3. Can this fraction be simplified further? Yes, Joseph, can it be further simplified? Yes, right? So what do we get? Negative 3. Okay, very good. So we can simplify it further. Negative 6 divided by 2, 4 divided by 2. Okay. So therefore we get these two answers over here, positive and negative. So therefore we have these solutions now. Alright? Any questions? This one factorized fully is like that. This is the full factorized form, but the question wants you to solve. Okay. Now let's look at try 18. We want to show that it has only one real root. Okay, so what is the first thing that you will probably do? Seeing what do you think? What would you have done if the question is like that? Expand? Yes. Okay, so clearly we extend it, right? Solve it. So we got this. We let the expression be fx, let the polynomial be fx. So same process. calculator, determine what is the linear factor, long division, okay, and then factorize. Okay, I'll give you 3 minutes to go and do that process, okay, before we go into proving that it has only one rule. Okay, give you 3 minutes. What is I? I is Miss Pam. That's what is I. I is a complex number, okay? You will learn it further when you go into high levels of maths. Okay? So that's why we don't choose that one. Choose that one. You press continue, press number. You will find a teacher. You continue to press, we'll have an integer one. There is, alright. Huh? Yeah. here, factorize. Okay, that was my instruction, right? Factorize it. Okay, before I continue, I just want to address your curiosity about these two numbers that you see in your calculator. Okay, what exactly is I? These two solutions here, okay, are what we call complex numbers. Okay, that is the opposite of real numbers. Okay, you see that in our context itself, we keep talking about real numbers and all that. Real numbers are all the numbers that we're seeing. Okay, complex numbers numbers are things that are due to when you take square root of -1, okay, or square root of a negative number. Okay, square root of -1 is defined as I itself. Okay, so when you have I, actually it's a -1.93 times the square root of -1. Okay, but that does not give us a real number or value on its own. Okay, so that's why we express it in such a manner. Right? How the graph actually looks like, okay, in such cases, because we have x1 equals to 2 and then 2 complex values, right? Okay, that will mean that there's only one intersection on the x-axis itself. There is no other intersections. Okay, this 2 does not give you an intersection. So since we have already covered how cubic functions look like, okay, generally I would say that probably this graph looks something like that. Okay, whereby there's only one intersection here at 2. Okay, this one doesn't meet the x-axis at all. Right, so this is how the graph could possibly look like. Right, any questions? Okay, so just to satisfy your curiosity, in case you're wondering. Okay, so from here, how do we continue it with it to actually answer this question to show that it has only one real root? Okay, so since we're looking at fx equals to 0, that means that x minus 2 equals to 0, or x squared minus x plus 4 equals to 0. Okay, our concern is to just prove that there is only one real root. Our concern is not about finding out what exactly are the roots. Okay, so if the concern is about finding out to prove that there's only one real root, we can make use of discriminant, okay, to address this quadratic part over here. Because surely when we find out what is the discriminant, it will be a negative value. So 1 minus 16, so negative 15. Okay, our discriminant is negative. Okay, so that means that this quadratic equation itself has no real solutions. And this one is just a simple linear equation, x is equals to 2. Okay, so with these two portions, we can see very clearly there is only one real root. Okay, this one doesn't generate any real roots. So therefore, okay, fx, or rather answering the question clearly, x times x squared plus 6 equals to 3x squared plus 8 has only one real root. This question over here where we say that the graph of a cubic polynomial meets the x-axis at -2, 1 and 2. Okay, so what we can imagine about this graph itself, okay, given that it meets x-axis at -2, 1 and 2, that means that they are the solutions, okay, to when gx is equals to 0. So something that we can imagine, okay, is that maybe we could get a graph that looks something like that. For example, okay, where we have a -2, 1 and 2. says that it passes through 0, 12. So maybe this one is 0, 12. Okay? And yet, we have to go in reverse, okay, to find out what is this expression for this function gx over here. Okay, so how do we go about it in reverse? Okay, so from this graph is understanding, we need to be aware that this tells me that the roots of gx equals to 0. These are the three solutions to this equation itself. And with that process, right, we always do by factorization. And in order to have -2, 1, and 2, that means there are 3 parts to this gx itself, which is going to be 3 linear factors. So there is actually no need for you to write this down in answer. You need to be able to draw that deduction that gx will have these 3 things as a result of this being its solutions, being its roots, being its intersection with the x-axis. Very clear? But then there is a problem here. Because I can have these 3 roots regardless of whether I have a 1 over here, -1, I want -3 also can. There are many numbers that I can put over here that will result in me having these solutions. Correct? So in this case, what exactly is this number here? So I cannot actually assume that it is a value of 1. Right? It can be any number that can give me these solutions. So I will let gx to be equals to this, right? And in order for us to find out what is k, we make use of the fact that it passes through this point. So at this point itself, gx is equals to 12. All your x values are 0. And with that, we can find that this will be 4k and k will have to be 3. So there can only be one equation that will give you these 3 roots and also passing through this point. Yes. To write down k is a constant. You can, but I will not. We will take it that you know that they understand k is a constant. They are not important. So k is equals to 3. Alright. Then therefore, we know that the answer will simply be this. There can only be one expression, one function that satisfies all these conditions. So the answer is just short, like that. Any questions? So for the online learning on Thursday, I assume that we're going to have online learning. I will go through one more question for 4.3 before we end this section. So then I will give you the homework for 4.3. If you want to start on it already, I'm sure you can already. You have sufficient skills to do it. Then that homework, please let it be due on, can I have it due on Friday? And 4.3. So because I only got one more question that I want to cover on the online learning. So the online learning, I'll do that one question for 4.3. Then I'll go into 4.4 partial fractions. So then Friday we'll come back and may continue on partial fractions.